Hi guys, so that we are done with the top deals for the means clustering, I would like just to note very quickly that it is a very good practice that in the previous video, in fact, I forgot to tell you to keep the M2DH2 consistent across all clusters, M2DH2. You can also do so by adding the dollar sign before the M. If you add the dollar sign before the letter of the cell name, this means that the letter represents the column, and this will mean that the column will be frozen or will be fixed accordingly. So over here we want to fix the column so that when I copy this across, if you notice here, if I copy that across, it will become N2 DI2, and this is something I don't want. So I'm going to add here the dollar sign, and I'm going to add also the dollar sign before the DH, and then hopefully here, as you can see, even when you copy that across, it will stay as is. So Excel is pretty smart. All right, in this video, and then please, after doing so, make sure that you copy that again. And now you will have as you can see here, you will have 3, 4, 3, and so on. All is good. And you will have 1, 2, 3, 4, 5, all have some offers in them. Anyway, let's move to K-median clustering. We are going to now start a new sheet. In fact, I'm gonna in the assignment feature in Moodle, I already have these sheets available for you, all right? And these sheets are all populated. I mean, not populated, you have to populate them. So how are we gonna reproduce the 5 mid cluster? Basically, we're gonna go to the 5 MC cluster, as you can see here, and I'm gonna copy the whole thing. I will just copy up to here and go over here. And instead of these values, in fact, delete that, and we are going to use a K-median clustering instead of the K-means. K-means take the Euclidean distance, while the K-median focuses on the similarity concept. And with the similarity concept, I would like to direct you to this slide over here. And this is the formula that we would like to insert in Excel. The formula is basically a distance formula, and it is 1 minus the cosine similarity. The cosine similarity is this function, is this formula. So the distance that we would like to insert in the cell is 1 minus this. So it's going to be 1 minus the sum of the product of A and B. Product of A and B is like multiplication, so the sum product, so there is a function in Excel called sum product. So it's going to be 1 minus, and actually I'm going to open up here a parentheses. So 1 minus the sum product of this first vector multiplied by the second vector, and they are both separated with a comma, over, and open up here to start a new parentheses, square root, SQRT is a function for the square root of the sum, so open here, sum of AI squared. So over here, excuse me, this is multiplied by the square root of the sum of the second vector, and please do not forget the square. And now this is the function 1 minus the sum product of this over the square root of the sum of ai squared, the square root multiplied by the square root of the sum of b squared, and then we don't need here extra space, and this is open, this is a closed, and this is a closed. There would be one more also here. And then we need to account for the fact that if there is the denominator here is not a real number, and it's happened to be a 0 over here and 0 over here, so 0 times 0 is 0, so anything over 0, so we need to account for this error. It will give me an error. So I don't want to be given an error. Instead, I want to be given a value 1. So if error, give me the value 1. So if error starts actually with the normal situation, if it's regular, give me this. If error, give me here, there's a comma, give me the value. Or perform as a different calculations. So now we're going to get rid of this, and instead we're going to use the if error 1 minus, and here sum product of what? Of two vectors. The first vector represents the client and hit comma, and the second vector is this vector, and this vector here is actually the cluster vector. So it is you can call the cluster vector, for example, here before you start writing this formula, before even typing this formula, you can just stop that, and let's do this. And for cluster 1, you can call it centroid 1, for example. So cent 1. So this vector now is called cent 1, and all this area we call it cent 2. So centroid 2. And this is the vector for centroid 3. Cent 3. So this is you make your life easier, and also it will make your life easy to translate the mathematics into Excel. Yeah, so let's do that. Finished here. So now let's go back again, and here's the distance. Instead of the Euclidean distance, we're going to use the similarity concept, or the cosine similarity distance. So if error. 1 minus, all right, sum product of the vector for the client, comma, the vector of the centroid. And actually, if you don't want to even go over, you can go over the, okay, you can go over like that, but you see, Excel is very smart, so it's going to realize that it is cent 1, or you can type it immediately. And then this is over, and open up a new parentheses, and it's a square root of the sum of the first vector, which is, as you can see here, it is m2 3. Over here, let's think about the future. I'm gonna drag this down, and when I drag it down, this m2 will be dragged down. So I want to stabilize it, not stabilize M2, because when I drag it to the right, I want it to actually shift to the right, but I don't want it to shift down. So in this case, I am going to freeze the number of the rows. So I'm going to add here the dollar sign. Okay, actually the same applies over here, right? So, and this is the sum here inside, so we're supposed to add to the power of 2. Close that, and that will be the square, right? Yeah, and then multiplied by the square root, and then sum, and then again the same, cent1. So you can type it cent1 here like that. We'll find it for you. And then please don't forget to the power of 2, because I did, and thanks to Anna, one of my students, who reminded me that, hey, Sensei, where is the power of 2? So now we closed. You see that this is purple and this is purple. This is closed. Now this is still open, so we need to close it. We close it like this. So this is the formula. However, when this is the normal situation. However, if there's an error, return 1. And now, if you hit enter, it's okay, but hit Control Shift Enter, even better. Now let's bring it down and make sure that this, instead of cent1, we call it cent2 here, and also cent2 over here. So this is the distance from centroid 2, or cluster 2. And now over here it's going to be cent3. Do you see how easy this makes it when you name the range? So when you name the range, things are easy. Even you can, and look, it is not dragging down. If you found out that this blue one and red one are actually shifting down, it's because you don't have that dollar sign. So please make sure you fix that also, either manually or as I did it with the relative referencing. Okay. Perfect. And now we can drag that here. And now we are ready to rock and roll. So now the distance measure is all right. I hope so. And this is the objective function, sum of all the minimum distances. And also we need to set up the optimization problem. So the optimization problem, the objective function here is this, the total distance. And we want to minimize that by changing the centroids over here. And then we're adding here a constraint. As you guys know, the idea of using this kind of distance measure is to constrain the vectors into binary, 1 and 0. And this is chosen here, binary. So add that. And now the options, you go to evolutionary, add a 0 over here. And over here, you can add 1, 5. And over here, 600. And then hit OK and run it. It will take forever, at least on my computer. On my other computer, it really runs fast. So I'm sure some of the students have it running for like 1 or 2 minutes and giving them a certain solution. Now, guys, as a reminder, I do have Okay, I do have on our business communication here page, I do have the solutions, the cluster assignment solutions over here, cluster assignment solutions. So please open up the file. I have the, so I'm gonna stop it for now. I'm gonna stop it for now to save the time. And instead, I'm gonna open up this cluster assignment and hit to 5 median cluster. I can do that, but you guys please wait for it to run. Give it some chance to run. And now this is a solution that gives us 85.82. Let me just make sure that I have oh, okay. I have a problem with this formula. It doesn't have to the power of 2. So this is the problem here. Okay, so in any case, now this is, let me just hit solver and I will also verify if this is the minimum distance that we could get. And this would be the solution. And now, as you can see, with this assignment as 1 and 0, you can easily say for cluster 1, these offers 29, offer 30 belong to it. For cluster 2, offer 27, offer 31 belongs to it. And also the beauty of this method is that we can see that offer 31 appears in more than one cluster. Appears in cluster 1, in cluster 2, in cluster 3, and cluster 4. Here, as you can see, 1, 1, 1. So that is also quite interesting that you have the same offer that appears in more than one cluster. And it makes it easier for us. And there's no guessing. It's just a very clear cutoff value. 1 belongs to it, 0 doesn't belong to it. Way much better than the loading table that we ended up having with the normal k-means clustering. All right, so this is the end of this video. In the next video, we're going to talk about summarizing the data. In the next video, I warn you that I might have different distance measures and values while performing the analysis, and this is due to the fact that I recorded all the videos and I forgot to add this to the power of 2. As you can see here, a to the power is a squared, so it's the sum of a squared. So I forgot to add to the power of 2 in the previous video where I already recorded and took it from there for the next video. So this video actually recorded the day after I finished recording all the videos. It's because I forgot to the power of 2, the square here. So if in the next video you will, I'm telling you that you will find different results here and different readings and different cluster assignments, then you will have different cluster assignments than what you will have over here. And I apologize for that. But the steps are the same, all right? They're straightforward and they are the same. Thank you so much.